So we are going to resume our session on the now neural network side. Starting with the error backpropagation. So I just want to know, what do you know about neural networks? Today is the third day. So what you have learned up till now in the previous classes? Basics of neural network you know, right? So to a neural network we give an input, and that input is then multiplied with the weight. Weight is the connection between the neurons and the inputs, right? Or between the two neurons there is a connection, and each connection has some strength, that is called as weight, right? So learning in the neural network is done on the part of the weight, because input is fixed, right? Our activation function is fixed. What is the variable left? That is the weight. So learning is done in the form of weights only. Yes. Yes. Actually, practically means we are artificial neural network is a copy of our biological neural network, right? So in our brain there are some chemicals, NaCl chemicals are there, and also some electrical signals are being generated, very small in microvolts are there, that we measure in the form of EEG. So that comes when the neuron fires. Fires mean when it gives an output, then we say the neuron is fired. So what you are saying is the weight of the how we can define weights practically. This is you are saying, no? So this is the amount of signal strength that is being generated from it, right? So practically, I can say only this. Okay. Some means chemicals are there, but is their strength. So because we are learning in that sense only. Firing there means that some signal is there, it is being fired, and that going beyond the threshold level.
In the case of
yeah.
Chemical.
Yes. So from that, some electricity is being generated. No?
Case of
Okay.
in that case, what it
In case of artificial neural network, we are just defining. Means practically it is not there. We are just defining the weight of a neural network. What is the product? Product is also there, no? So we are saying that this line has this much strength. According the strength is being or the weight is being assigned according to the output with what we are requiring, because error is being calculated. This is a control system, like we are changing the outputs. In the control we are changing the input, but here we are changing the weights according to the output requirement, right? So in the this is one form of the neural network in which error is being back propagated. The signal flows in the forward direction, and the error which is being calculated that the output propagates. Means back propagating the error, and how we are doing it, right? So in a neural network we define first of all an architecture is there. Architecture means the number of neurons, how many layers are there, this we define. Means 3, 2, 1 means we are using 3 layers. First layer is having 3 neurons, second 2, then final we are having 1 neuron. Output will be 1, input will be 3, right? So between hidden layer and input layer there will be a set of connections. Then between hidden layer and output layer there will be a set of connections. As you can see on the screen, there are 3 to 1 is there, right? 3 input, 2 in hidden, and 1 output neuron is there. And x1 and x2 inputs only 2 are given, and each neuron is connected to every other neuron, right? So in case of actually in this network, we are using the delta learning rule. What is a learning rule? The rule with which the weights are being updated. What is the rule being followed? It is given by different persons from time to time, and accordingly the name is being given to their rules, right? So this is a delta learning rule in which a delta is being calculated depending upon the desired signal, desired output which is there. So the error between them multiplied by the derivative of the output will give us the delta. So for the every learning algorithm, how we update the weights? Previous weights plus change in weights. At each step, what we do? There is a change in weights according to the means according to the error, right? So that are being added or subtracted to the present weights. Now, the present weights are fixed. There is a change in the weights, and the change in the weights is dependent upon the parameters R, C, and X. What is R? R is the learning signal, C is the learning constant, and X is the input. Input is fixed, learning constant we keep it to 0.1 to 0.9. So for a change in weights means W T plus 1 is equal to WT plus delta WT, right? So this delta W, this is the present set of weights, and this is the change in weight. Calculated according to the error being calculated, right? And this depends upon RC into, right? This R is the learning signal, this C is the learning function, and this is the input, right? So C is kept between 0 and 1 value, nearly 0.9, 0.8, and 7, like this. Should not be too high, should not be too less, right? And this now our left term is R only. So R is being varied according to the means given by different persons. So this is the only signal which is contributing to the change of weights. So in case of delta learning signal, this R is called as delta, right? So there are many other learning rules, Hebbian learning rule, the Saccone learning rule, correlation, winner takes all these are learning rules are there. The change is there, you can see there is a change only in the R signal, right? So in case of delta learning rule, when we are calculating the final output Y, and let us say there is a desired signal D is given. So how we calculate the delta? Y minus D or D minus Y into Y dash, right? Whatever it is coming, that is multiplied with the derivative, this is the delta. Now, the delta is being multiplied by the Y desired, means delta is calculated if we know the desired value. But in case of hidden neuron, this is our input layer, In case of here, the desired output is available. So we are calculating delta, right? But here, what is the desired output? We don't know. What is the desired output here? So how to calculate delta here? यहाँ पर delta क्या होगा? What is the value of delta here? Yes. Can't calculate delta here because for the delta we need the desired output. We don't know the desired output at the output of these given nodes. So what we do, we back propagate this delta. Why the back propagation of error is there? Because we are not having any desired output at the hidden layer neurons. So at the output we calculate the delta, then we back propagate this delta to these neurons. Right? So this is the only thing in the error back propagation. Clear? So I am also showing this from your from these slides. As you can see, this is Wx1, Wx2. How we write the weights, that you know. This is the subscript of the last neuron, then subscript of the first neuron. Then this is W11 or W, then 12. This will be W21, W22, like this. Now this is the Y1, which is at the output of this neuron, right? So Y1 is equal to Wx1 into X1, means this input is being multiplied by this weight, then plus X2 into X2 into X21, right? This will be the Y1. Similarly, Y2 is equal to F2 is the function, which is the threshold function. Oh, sorry, activation function. Activation function is what? To getting the output in our range. If we want to get the output in the range of 0 and 1, then hard limiting functions we are using. If we want, there are hard limiting functions and soft limiting functions are also there, right? Similarly, binary and both sided positive and negative side functions are also there. Sigmoidal functions are there, right? So Y2 is equal to the Wx1 into X1 plus this weight into X2. Similarly, Fy3 is being calculated like this. And this, within bracket, this term is called as net. And when you apply function on the net, you get the final output from that neuron, right? Similarly, you will get Y3, which is equal to X1 into this weight plus X2 into this. X4. So this is, now we are going in which direction? In the forward direction, right? Moving in the forward direction. So Y4 will be calculated. Now the output of this F1, this neuron, first neuron, will be the input for the fourth neuron, right? Similarly, output from the second neuron into the input to the fourth neuron. Third neuron is also contributed to the input of the fourth neuron. Similarly, all these three inputs are being contributed to the as the input to the next neurons. So Y4 is equal to W14 into Y1 plus W24 into Y2 plus W34 into Y3, right? And then F4 function is applied on it. Similarly, F5 you can calculate, which is equal to W15 into Y1, W25 into Y2 plus W35 into Y3 with the activation function F5, right? So remember all these things because we are going to implement it in the codes also. We are going to make a code. So Y, now we are calculating the final Y. Now these Y4 and Y5 is input to the sixth neuron, that is the output neuron. So Y is equal to F6 applied on W46 Y4 plus W56 into Y5. So we now have calculated all the outputs from all the neurons. So we have now moved into the forward direction. Now we will start moving towards the backward direction after calculating the delta, right? Delta. Delta is equal to Z minus Y. The Y is coming, the Z is the desired output, we are calculating it, and then this whole is being multiplied by the derivative of the Y. जो Y and output आएगा उसका हमने क्या लेना है, derivative लेना है, and that is to be multiplied by the error. This is error. Error multiplied by the derivative gives us the delta, right? Now this delta is now being propagated in the backward direction for the other neurons, because this delta has to contribute for the weight updation. Delta 4. We are at the fourth neuron, we will be having delta 4, which is equal to delta into W46. Means when we were coming from the in the forward direction, the signal was being multiplied by the weight. Similarly, when we are going backward, the delta will be multiplied by the weights. So delta 4 is equal to W46 into delta with the derivative of this Y4 derivative, right? Delta 5 is equal to same W56 into, because it will be now coming to this side, so the strength of this will be multiplied by this delta. So delta into W56 into derivative of this fifth output. Now delta we have calculated, delta 4 we have calculated, delta 5 we have calculated. Now for delta 1, 2 and 3. Delta 1. Now delta 1 means the path which is going from 1 to, it is going from 1 to 4 and 5. So the delta from both these will be contributing for the calculation of delta 1. Remember it, right? Because the connection is from first neuron to the both of these neuron is there. So delta 4 multiplied by W14 plus delta 5 into W15 whole is being multiplied by the derivative of this output, that is derivative of Y1. Clear? Right? Then for delta 2, what you will do? You just speak, then I'll shift this slide. Delta 2 is equal to delta 4 W24 plus delta 5 into W25 whole multiplied by derivative of Y2, this, right? Then delta 3, W34 into delta 4 plus W35 into delta 5, and whole is multiplied. There is a bracket. The whole is multiplied by the derivative of this Y3. So now we have calculated delta at all the nodes. Now the next step is to find the updation of the weights, and updation of weight is RCX, then adding this change in weight to the previous weights will give us a set of new weights. See, starting from the input W, now we are writing W dash, right? Updated weights will be W dash, that is equal to previous WX1 plus eta. Eta is the learning rate into delta 1 into X1. Delta we had calculated, eta is a fix, X1 is the input to that neuron for a particular weight, right? So for WX1, what we are doing, we are just adding the present weight with this term which is eta into delta into input. For this weight updation, W dash X2 which is equal to WX21 plus eta into, here delta 1 will be being contributed into, but the input is being changed. Input is x2. Then coming to this w dash x12. Now here w dash x12 plus eta into delta 2, because now it is from the neuron 2, but here the input is x1. For this weight the input will be x2. So see, there is a change in the inputs, but with the change in the neuron the delta is also changing. For this w dash x31, now this derivative is being written here. This should not be there. It should be eta delta 3 into x1 only. Then eta delta 3 x2 only. Because this derivative we have earlier, this is wrongly written here. Similarly, W14, W24 and W34. This is W14 plus eta into delta 4 into Y1. This is eta into delta 4 into Y2 and Y3. So you have now learned the concept of delta learning. So we are implementing just for the back propagation. And why we are back propagating the delta, that I have told you, because for the hidden layer and neurons we are not having any desired output. That's why we have to back propagate the delta, right? So similarly we update all these weights at all the layers, right? So this is our motive, is to update the weights. Now weights are being updated at each iteration. Now the iterations will, how long means we have to iterate the program. We set a some condition is there. Either the stopping criteria. Each program has some stopping criteria, means when the execution of the program is to be stopped depends upon two things. Either the number of iterations you have to give, that the loop should go up to, let us say, n equal to 100, or you give the condition, error conditions, means the error, what error will be calculated? Mean square error will be calculated, means the error between the desired output and the output which is being given by the neural network should be in tolerance to this value, right? Means 0.001 error you can put, or 0 error you put, whatever you want to put the condition, you can put to the stopping criteria. So when that error is being met, this means now the neural network has learned. Then after the training process, this is called the training process, then the 6 sets of weight which is being returned, that are being used for the testing purpose, right? Then the neural network is being tested. For the testing purpose there are various, means data set is given, inputs is given. So the let us say 10 inputs are given and the neural network is giving us the desired result for the 8 number of inputs. So then what we say, that is 80% accurate. So the accuracy percentage is also there for the neural network. So that is up to your application, that how much accuracy you require, right? So according to your accuracy, you put the condition for the error also. Clear? Any doubt up till now? No. So this is, now we are moving towards the code for the neural network. This is just the display error back propagation network, and this is the input. This T is the output, which is also we have to provide, because desired output is required. So for each particular, because for the training we also require a particular set of data. We can't train a neural network with only one data, one input. So we have to provide a number of inputs. For various inputs, the neural network, we have to give the desired output also. So T is the desired output in this program. And then for the starting, we have to just initialize the weights, right? Weights, now there are, if we are using 3 to 1, let us say, or 2 3 1, right? In our example, this is 2 3 1, 2 input layer, 3 hidden layer, and 1 is the output layer. So 3 layers are there and 2 set of weights are there between hidden and input, then output and hidden, right? So first we have to initialize the weights. Either we can randomly initialize by using the command rand, or we can initialize all the weights from the zeros, or we can fix the weights from the 0.5, 0.8, whatever we want to give. So we are having these three ways of initializing the weights. So after the initializing, let us go to the Scilab and let me explain from there also only. This is the program, right? This is the input you can give. This is put in the commands. Now this is the input. X1 is given as 1, 2, 3, 1, 2, 1 and 0.1, 0.1, 0.1 and 0.2. So this is the set of input which is being provided. T1 is the target in outputs, right? 1, 2, 3, 4, 5 data sets are given to us. Now this is the WHI is the set of weights between hidden and input layer. So any name you can give, W, WHI or just any other name you can give to the weights or any other thing, right? So this is randomly initialized ran2, 3 because in the if we are using 2 and 2 input and 3 hidden layer, how many sets you require? 2, 3 because each neuron is connected to every other neuron of the hidden layer. Then WYH is between output and hidden, random 3, 1. Then L is the size of x1, 1. Now size is a command which gives you, which returns you the size of the matrix, right? It will give you how many rows and how many columns are there. So that is being stored in the variable L. Then MSC is being initialized, means we are fixing the variables for all these which are being to be used in the code. MSC is mean square error taken to be 0. Initially lambda is fixed to be 0.69 lambda or the eta value which I showed you in the eta. Then display weights, this is up to you. Then C is equal to 0.8, that is the learning constant. Lambda is the learning rate or eta, then C is the learning constant. Then E is equal to 0.01. Initially it is being kept, it is equal to 0.001. Error equal to 0. Net zeros L, 3. This is L 1, 3. Then out zeros, means these are the variables which are being kept aside by initializing them some value equal to 0. Fnat, fnout, out, all these. Now the main program starts from here. While error equal to 0, जब तक error क्या है 0 है, then this loop will go on executing. So this is the while condition we are using. Then net zeros, out zeros, all this. Now for I equal to 1 to L, what is L? It is the size of the input. Why we have taken the size of the input and we have put it in the L? Because we want to execute the loop for so many inputs. Let us say we are having 10 number of inputs, right? We want the neural network should take first input first, update the weights, then take the second input, update, third, fourth, fifth, like this. So how many times it has to go, that depends upon the how many number of inputs are there. So that's why we calculated, we put the command size. From the size we took the how many rows or how many inputs are there, and we are using it in the for loop. For I is equal to 1 to L. L तक जाएगा जब तक सारी inputs को वो cover कर लेगा. Then calculation of hidden layer output. For k is equal to 1 is to 3. For j is equal to 1 is to 2. Net, we are calculating the net value. Board पे बता. this set of weights what we have given W x, right? And this is W x y or y x. So what we have done for k is equal to 1 is to 3, for j is equal to 1 is to 2. Means first we have to calculate. This loop will go on. First k is equal to 1, k is equal to 1, right? For this, when k is equal to 1, j is equal to 1, this will be calculated. Means now x1 will be multiplied by this weight, right? Because this here net is equal to this into this, x1 into this, x2 into this weight plus these two, right? But then what we say, first x1 into this plus x2 into this. We will get net value here, right? First we are calculating the net value. Then function is applied on it. F of net. F of net is equal to 2 upon the function value is equal to, here we are using f of net is equal to 2 upon 1 plus exponential minus lambda net minus 1. This is the function we are using. Yes, this is the activation function. Sigmoidal activation function is being used, which is given by 2 upon 1 plus exponential minus lambda into net. Net what we have calculated earlier, which is the product of the inputs and the set of weights, right? Then after calculating the f of net, we are now, this is loop. For the loop, we have now calculated the output for each of the hidden neuron. Because in the hidden, we were having 3 neurons, right? So 3 outputs we are getting. I is varying from, I is going from in 1 to L and K is going from 1 to, yes. So these F net and net is being calculated. Now coming on to the output. For the output we are calculating F for K is equal to 1 is to 3. Now this depends upon the number of neurons we are being taking. 1 is to t, out 1 is equal to out 1 plus f of net into wyh. Now this is out 1 is the output of the this last neuron. Now the output for the last neuron is the input from the all these 3 neurons, right? So this is for k is equal to 1 is to 3, output neuron output is equal to this plus this. Then we can also take the bias inputs also. These are the normal inputs we are having. So there are also bias inputs. Bias inputs can be given either the value of 1, minus 1. Now these are given to change the output. Let us say we are not getting the output, then we can connect the bias inputs also. And those bias inputs will also have some strength. They will also carry some weight. So that weight is also needs to be updated according to the same procedure what we are doing, right? So only difference is that bias inputs are fixed and they can be used according to the input, right? Sorry, according to our output requirement. Then f out is being calculated. F out means the function is being applied 2 upon 1 plus, see here, exponential is exp within brackets minus lambda into out 1, right? Now next is di. Now we have calculated all the outputs. Now what is the what we have to do? We have to calculate the delta. For the delta, this is equal to T1 minus f of out 1. This is the error, means desired value minus the output which is being coming. So DTI target value minus the f out into lambda by 2 into 1 minus, this is the derivative. Lambda by 2 is taken for the cancellations of these constants, right? So this is the derivative is being taken. Then mean square error is being calculated at the output, because we have to check whether or the output which is coming, it is equal, how much it is nearer to our desired output and how much error is there. So we are calculating MSC, which is equal to mean square error. Then modification of weights. Modification of weights means this lambda will be carried out in the backward direction, and side by side we are also modifying the weights. Which one? Lambda by 2 is extra to this derivation. Means you can also exclude this. This is being taken for the convergence purpose only, because for the what we want that our neural network should converge. It should not oscillate. Our requirement is that it should come to a minimum value. Minimum value of what? Of error. Our error should, with each iteration, it should go on decreasing the error. So for these purpose, sometimes we have to change the hidden layer neurons and learning constant, learning rates. All these have to be adjusted accordingly. So now the modification of weights, which is equal to, for k is equal to 1:3. This is the input neurons. Now you are familiar, WYH means from the hidden layer to the output, right? So WYH K1 is equal to F of net into Ci into Di. F net is the output from the F net is the out from the output neuron into C learning constant. Sorry, F of net is the output from the previous, because it is now the input for the output neuron, right? Into C is the learning constant that I was telling you, RCX. So R Di is the R, means delta value, into C into input, which is the F of net. So this way the updation is being done in the one line only, that I have explained you earlier. Now for k is equal to 1:3, next you see another set of weights we have to now. Now this is being calculated delta for the previous neurons. Now we have side by side we are calculating the delta, and also we are updating the weights, right? So propagating back the delta. DHK is equal to DI. फोन है Yes. So this is the modification of weights for the output. This is for k is equal to 1:3 WYH into K1. Why we have taken it is 1:3? Because the input to the output neuron is coming from the 3 neurons of the hidden neuron, right? So this is previous weight plus output, which is for the input for the output, into this is the learning constant into delta DI, and this is end of the loop, right? Now next is we are back propagating this delta to the hidden layers neurons. So for k is equal to 1:3, DHK is equal to DI, which is the output delta, into WYH k comma 1, because every delta has to be multiplied with the weight, into lambda by 2 into 1 minus F of net into square, right? So we are just back propagating, because this is the derivative of the output and it is to be back propagated for the hidden layers, right? Then WHI, here we have calculated the delta for each neuron in the hidden layer. Now we are updating the weights of each hidden neuron. So WHI JK is equal to WHI JK plus x1. Now we are taking the input x1 into C into D HK, right? Similarly, x1 and x2 will be there, because as I and j will be changing, this will be changed, because this is, we have put it in the matrix form. So when I will be 2, it will automatically goes to the second input, right? Now we have calculated outputs in the forward direction, we have calculated the delta, we have back propagated the delta, we have also updated the weights up. Now finally what we are checking, the condition. If maximum of MSE is less than E, then error you put equal to 1, else error equal to 0. And then plot y comma maximum of MSE with this plus sign, means the plotting will be now with the plus signs. You can put minus signs with stars, right? Then x title of the graph is there. Then you are doing y equal to y plus 1, because with each iteration each MSE will be there, and with each MSE you are plotting y comma MSE, right? And then finally this end of the while loop, right? Let us execute this program. So when you execute this program will converge to a minimum value of error. So that minimum of value of error will be achieved, and that point we get the, means the optimized weights. For those weights now the neural network is learned, and now we are able to get the required results. See, our network is being executed, and this is the MSE we are plotting. So this is the, you can see the error is going on decreasing. The number of iterations goes up to 130. So this is up to you how much condition you have to put. So with each iteration, as you can see, we started from the error of 0.075. So it moved up to 0 up to the 30th iteration. So now you can see the set of weights what it has returned, means at that time. What were the substrate with W, H, I? These are the weights. Then W, H, Y. W, I think Y, H. So these are the set of weights which are being given by the network. For these weights we are getting the error equal to 0. So what we say, our network has been trained and converged to the error equal to 0. Right? Any doubt? It is clear? Now any doubt from any center? Then we move to the next program, that is particle swarm optimization. So I will just give you an idea of PSO, right? How to execute it and what it says, right? For a particular particle swarm optimization, this is an optimization algorithm which is being copied from the behavior of birds, right? What birds do, how they find their meals, how they fly so distance, and they how they communicate with each other. Means if one gets a food in at one place, how the others are being communicated that yes, the food is there. So that algorithm is nature inspired from the birds only. So for that, means we want to optimize some problem, and that problem is written in the form of an equation, and that equation is called as either an objective function or the cost function. So in optimization problems, either we have to minimize or maximize. So cost function or objective function has to be minimized or maximize. So for each optimization problem, first you have to set up your cost function, what you want to achieve, right? So for this we are just generating a population, POP, which is randomly generated, let us say 100, 100. 100, 100 means now you are very much familiar what it means. Means 100 rows and 100 columns are there. N is equal to 50, the number of iterations you want to do. Now the stopping criteria I have put is either 50 or you can put anything, thousands you can also put, and also the error stopping criteria can also be put. So these are the parameters which you have to fix, M2, M1, A, B, all these selection rate what you have put. Then in the PSO there is a term global best and local best, right? Local best means when a particle finds the something which is optimized in a local sense. Local sense means in his own lifetime what it has achieved. That is locally found. Globally found means when all the particles, now here the particles I have put as 100, 100. So many particles are there. Either I can take only single particle according to my cost function, or I can take in a full row or a full column as a one particle, right? So the global best means whatever the whole of the population has achieved is called as the global minimum or the local minimum, right? So these are the two terms which we'll be using in PSO, and there is a term velocity and distance. I mean that is the term because it is being connected with the bird. So this is a term velocity and distance. So each has to maintain their velocity and then update the distance. Here also updation is there according to the parameters G best, P best, and some other parameters, random parameters, right? So here this is the equation, main equation for the PSO. Velocity I comma j is equal to, this is the parameter previous or the initial velocity, 1 minus population particles which velocity is there divided by G best divided by M plus C1 into random. These are the constants multiplied by the random. Why these are there? So that our algorithm should not get stuck in the local minimum. Because what we require, there are also local minimas are also there, global minimas are also there. But we want that we should achieve a global minimum point. But so the randomness is being provided to so that our algorithm should not stuck to the local minima, considering it as the global minimum, right? So this is P best minus, P best is the distance or the position of the local one, then one particular particle's position plus C2 into random number into G best minus that number. So this is the basic equation for the PSO. This is the single equation. As you can see, these dots, as I have already told you, this is the same line. Then if velocity, all these have been, conditions have been put. You can also put the search range also, minus this to this. Similarly, velocity will go on improve. When you are updating, it will go on may across the range also. So you have to put a condition also here, according to your requirement, that the velocity or the updation value should not exceed this much amount, right? So these are all the conditions put on the velocity. So this code is not written means just a code for PSO. Some modifications are also being done to it. So population, POP1 is velocity plus POP. Because our motive is to, we have just initialized the population, initialized the particles. We have to return those particles which minimize our cost function. This was our objective. Objective function is there. The objective functions will be containing some variable. Let us say objective function is x square plus this, x square plus y plus 2x this. Some equation is there. We have to minimize it. This is the simplest equation. we have to minimize it. Now the variables are here x and y. So we are creating the population for x and y, and then according to the velocity we are updating these values of these particles. Pop is equal to velocity plus pop, means this previous plus this updation. Updation is being done by adding this velocity, and velocity is calculating that from that equation, right? So our motive is to return the values of those particles which are going to minimize that cost function. And for that then we are checking this if cost j is less than cost k, because for each objective function or cost function we are calculating the cost, means we are calculating the value which we have to minimize. If it is less than j, then we keep the p best as the p best for that particular, means let us say some particle is here and then at the next iteration it goes above to that. Yes, then we have to keep the previous position as the global minima by checking the cost value of all of both these positions. Understood? If the next iteration, from the next iteration we are getting the minimum value, then we will keep the updated value, else we have to preserve the previous value. That's why we are checking here the cost of j and cost 1. That's why we are keeping, we are here, cost is equal to Rosenblock. Rosenblock is a benchmark functions are there for calculating for checking the algorithms. There are some standard functions, benchmark functions are there. So Rosenblock is one of the function, right? The cost is being sorted, it is being calculated according to each iteration it is being calculated. And for each iteration cost is calculated and it is being checked whether the previous cost was less or this one cost is less. If the previous is best, then we keep it as P best. Previous one, else we will keep the present one. Then P best is equal to pop 1. Now if cost, now for each iteration P best of each particle and G best of the whole of the particles will be updated, right? So this will be G best is equal to pop of 1, and this is being calculated from here because we have calculated sort cost for each particle will be there, a matrix will be there and it will be sorted. It will be sorted in from decreasing to increasing order, minima to maximum. So according to that the global best is being calculated, G best is calculated. So the sum means you can what you want to display, error you want to display or cost you want to display, all this depends upon this what you want to display. So this iteration goes on, and after the either I have put on the number of n, means n I have put equal to 50. So the stopping criteria I have put is the number of iterations. So you can also put according to the error. So this is the code for the particle swarm optimization. Clear? Anything you want to know from this lecture? If there is any doubt you can ask. From other centers also you can ask, you can raise questions. So from my side it's over. अरुण सर कौन कौन से सेंटर्स हैं?
Hello, madam.
Yes.
So when you are going to define the G waste, there is a chance of will trap in the local minima. So how will you avoid that?
No, for the G waste first we are calculating the cost for all the particles.
Yeah.
Right?
Yes.
So as I told you in the equation only, we are providing the randomness in the equation so that we don't get trapped in the local minimum. And for the G waste, we are taking the minimum value.
Only one minimum value is not sufficient. No? There is a chance of so many minimum values in between local to and global minima.
No, no, no. There will be a means trend for the minimum values. There may be many, but one minimum value will be there. That will be taken as the G best, and it will be updated with each iteration.
Okay, madam. Thank you.
Excuse me, ma'am.
Yes.
Ma'am, is there any option for interfacing both model and the program so that I could retrieve some data from the model to the program?
Which model?
Ma'am, is there any option to interface the Simulink model and a program?
Yes. In the previous session, I have told you the user-defined functions.
Okay, ma'am. So
Yes.
from that function, we could get the program.
Yeah, yeah. You can get the program in the blocks also, in the models also.
Okay, ma'am. Thank you,
Yes.
ma'am.
Hello. Excuse me, madam. I am from Rubber Engineering College. My name is Martin. Are you hearing me?
No, please speak loudly.
My name is Martin Gupta from Rubber Engineering College.
Yes, sir.
Small doubt regarding Scilab.
Okay.
What is the main limitation and difference between Scilab and MATLAB? What are the major differences and limitations of Scilab compared to MATLAB?
Please use the laptop mic. Switch off the external mic.
Ma'am, now you can hear. Hello?
Yes, sir.
Madam, what are the major limitations and drawbacks of Scilab compared to MATLAB?
Okay. So advantages, you know.
My name is Markandeya Gupta from Raghu Engineering College.
Okay, fine, sir. Sir, I am asking, do you know the advantages of Scilab over MATLAB?
MATLAB, I am experienced with MATLAB, but I am
Okay.
new to Scilab.
Okay. Why do you want to know the disadvantages? First, you know the advantages of Scilab.
I know that Scilab is freeware source, but is there any? I want to compare with MATLAB. That's
Okay, okay, fine. So MATLAB is is closed source program code, right? And Scilab is freely available. This is the advantage main, and you want to know the disadvantages. So it is somewhat slow as compared to MATLAB. The number of instructions or the commands are less as compared to the Scilab. These are the only two disadvantages of Scilab.
thank you, madam.
But you can also call the MATLAB commands in Scilab also using the command mtlb underscore that I have told you.
Okay, thank you, madam. Thank you.
Excuse me, ma'am.
Yes, ma'am.
Uh, there is any execution time comparison with MATLAB and Scilab? Because when we are using a GA program in MATLAB, the execution time is very high. There is it takes off some 1 or 2 days to run. Is this
Yes.
time is decreased in a Scilab?
Actually, GA itself is having a so much execution time. So whether you do it in MATLAB or Scilab, that doesn't make any difference.
Okay, ma'am. Thank you.
Any other center?
Hello, ma'am.
Yes, sir.
Ma'am, actually, if you see in MATLAB, ma'am, actually, I was doing a VPN network code. Actually, we want to write a target, you want to write the and you may see and like everything is in MATLAB.
Your voice is not audible.
Ma'am,
Distraction is there.
uh, in MATLAB, if you see in MATLAB, ma'am, I am coding a VPN network. We are getting input, we are getting the target, and we are just getting the number of hidden layers. And there are inbuilt function like MAC, momentum.
Actually, I am unable to get you because your voice is breaking. There is a break in the signal.
Uh,
Yes, please carry on.
is it audible?
Yes, yes, please.
Is it audible, ma'am? What, ma'am?
Yes, yes, please.
Ma'am, actually, only one doubt is, ma'am, if you see in Scilab, we are writing entire code. So, starting from in the program that you are teaching us,
Yes, sir.
we are writing the entire code. So every step we are writing like the calculating the error, backpropagation, everything. But if you see in MATLAB, like we want to give the input, we want to give the target, we want to give the MSC and the inbuilt functions in MATLAB. Similarly, is there any inbuilt function in Scilab? Instead of doing the entire program, it takes a huge time. Instead of doing the entire program, any inbuilt function that we can, like, if you want to do VPN, KPN, BPN, CPN network, there are inbuilt functions in MATLAB. Is there any inbuilt functions in Scilab?
Okay, okay, fine. But I have got you. You want to know the means inbuilt function for the neural networks,
Yeah,
right?
yes.
Yes, yes. It is there in the neural network modules as toolbox of neural network there in MATLAB. But you write ANN, FF, feed forward, all these. So actually, I haven't gone through these toolboxes.
Okay, okay, ma'am. Okay, ma'am.
Okay, otherwise it is there in the modules only. You can download, but I have told you, I think you must have heard about that when I
Okay.
told you. You can download that neural network module.
Okay, ma'am. Okay, ma'am. So if topic, if you detailed description about that neural network model is given to you, instead of writing the entire code, if you like description about the model, about that code or description, it will be please.
Actually, I don't prefer modules.
Okay, okay, ma'am. Thank you, ma'am.
Next, from next time, I can come up with the modules description also.
Okay, ma'am. Thank you, ma'am.
Okay. Yes, NIST Orissa, can you hear me? NIST Odisha, Saint Xavier's, Mumbai.
Yeah, it's Odisha, ma'am.
Yes, sir.
Thanks.
If there is any question, query from your side,
No, ma'am. It's okay. Do that.
thanks.
Thank you, ma'am.
So, any question from any center, or I suppose that everything is fine to everybody? Riyat Bahram Shahpur.
Yes, no queries.
Okay, fine. Okay. Queries from this side?
Excuse me.
Thank you. Yes. Hmm. JCRC. Jaipur?
Hello, ma'am. Can you hear me, ma'am?
Yes, yes, please.
I am from JHS University. I have a
Okay.
query. Actually, ma'am, is there any specific advantage of using Scilab or MATLAB for neural networking, or it is just the general advantage?
The same advantages that are over MATLAB, same is with the neural network.
No specific advantage for neural
No
network.
specific advantages here. Same. Everything is